Well, hello friends. Welcome back to browser hacking. Today we are going to look at performance of GitHub specifically in the Serenity OS browser. And over the last week, I've been working on a bunch of layout improvements to better support sites that use CSS Flexbox, of which GitHub is one. And it's in a decent state. Still a lot of work to do, but the basic layout comes out. And now I'd like to investigate performance a little bit more because it's kind of obnoxious when you try to interact with the page that it's just very sluggish. So for example, it's a little bit bright here, but maybe these are easier to see. If I hover over these links, then you see that you get an underline from like a hover effect, and it takes a long time for that to show up. And presumably because we're doing something very, very busy down here, you can see the CPU spiking when I'm moving the cursor over the page. And today I'd like to investigate this and see what kind of steps we can take to do less work when you move the mouse around and, you know, profile, optimize, the usual good stuff. So without further ado, let's just profile right away. I think we'll just, let's see, what's a good thing to measure here? So like these guys have an hover effect as well, I think. Although I'm not actually seeing anything. Can't tell if it's too bright. Everything's really bright on screen. Okay, well, these definitely have one, so let's use those. Okay, so let's profile everything, and then I'll just move around here. I really just want to capture some of this. Okay. And then let's take a look. Why is it so sluggish? Okay, so we can already tell we have these big bursts of time happening in the web content process. We'll zero in on that, switch to percentages and inverted mode, and then pop it open. See what we can find. All right, so syscalls is at the very top, and that's inside madvise, which is a syscall that we use in our malloc implementation. So when you free or when you allocate something that requires making a new kernel allocation via mmap, we also call madvise to set up some additional page volatility bits and stuff like that. So it seems like we're spending a fair amount of time doing that. And that's allocation that happens in the CSS style computer class when computing the cascaded CSS values. So allocation business happening there, definitely heavy. And then we have a quick sort, recursive, presumably. Okay. And we are quick sorting. I think this is going to be stacking context. Actually, yeah, we can see that at the top here. This is when we are constructing the stacking context tree for all of the sort of Z order paint layers in the web page, then they have to be in a certain order. And we use quicksort to maintain that order. And it's something that we've definitely seen before in profiles and people have talked about seeing, but we never actually sat down and did anything about it. So that definitely looks like something we should invest time in here, because we have 13.5% in quicksort, just sorting the Z order stacking context layers. And we have 9% in CSS Selector Pseudoelement. So we recently gained support for Pseudoelements. Sam added that, and I think we have a little test page somewhere. Where is that? Pseudoelements. Yeah, so like : before, : after, and also : marker. Pseudoelements are now stylable with CSS. And in fact, Sam also added, I just want to show this off because it's so cool. You can see the Pseudoelements in the DOM inspector here as well, they pop up as these little purple things. They don't have a corresponding DOM element. They are sort of pseudo elements attached to a DOM element. Anyways, apparently extracting the pseudo element from a selector is very heavy on this page when I'm mousing around. So that's definitely something we can do less of or do faster somehow. So let's look into that as well. And then CSS style computer properties or computed value cascade looks generally heavy, sure. And then we have a hash map. I think this is going to be the custom properties hash map. It's the only hash map of string to style property that we have in the style computer. Actually, that looks really, really heavy because we got both of these two. Right, oh, actually, no, one is calling the other, sorry. But very, very heavy, 6.5% or so, just making the hash map or custom property resolution. Memset, oh, that's also in the custom property thing. Okay. Property initial value 1%. That seems excessive. So this is just a function that looks up whatever is the initial CSS default value for a given property. So this really should just be a simple lookup table, and don't expect to see that at 1%. But I mean, 1% is, now we're getting a little bit down in the weeds here. Let's try to stick to the double digit stuff, at least at first. So that quick sort, let's do that one because I think we can do something easy. The problem is, I'll show you. When we're constructing the stacking context tree, actually, let me show you what the tree looks like. So if you have a very, very simple page, let's open one. Like this page here that just has some text. It will have a stacking context tree because everybody has a stacking context tree. But this one is extremely simple. It's just a single stacking context because there is no Z order layers to care about on this page. It has no stacking context. You can see here, it just has a base layer with Z index auto. But for a more complex page like GitHub, which we have open here, if we dump the stacking context tree, we can see that there are substantially more stacking context layers or stacking contexts, right? So there's a couple of them. Nothing super crazy, but evidently we are still spending a lot of time sorting these, which is a little bit surprising, but let me show you how that happens. So when we're constructing this tree, when you construct a stacking context, you pass in the parent stacking context, and that's how the tree is formed. So you see the indentation here indicates the tree structure, right? So this guy here is less indented than this one. So this is a parent of that one. And when you insert a new child into a parent implicitly by constructing the child, we also tell the parent, hey, you got a new child, resort your children. And then this happens right here. And the way that we sort these is we sort by Z index, but if the Z index is the same for two sibling stacking contexts, then the tree order, so the document tree order determines who goes first and who goes second. So we use isBefore, which is a sort of a generic tree node comparison function that we have, and that's definitely not fast. Yeah, because it will just walk through the tree and locate and see if like this node is after that node in tree order. Definitely not fast. So the very, very quick fix here, I think, is not to do anything more clever than isBefore, even though we definitely could do something more clever than that, but to not sort on every append, just as the fix me indicates, but rather do a separate sorting pass at the end. So we would just do something like, let's see, stacking context sort, and We would sort our children and then iterate through the children. Something like that. And then let's add a sort function. And the sort function can be called after we build stacking context tree. Yeah, we only build it in one place. That's when we do layout. So build stacking context tree does all the work of setting it up. At the very end here, we can just call, wait, here it is, the stacking context. So I guess that would be paint box, stacking context, sort, and then I have to const cast, apparently. Yeah, we should take care of not having to const cast at some point. Or wait, hold on. I guess it's the paint box that is const. My bad. There we go. Okay, so I imagine that this will already help substantially. We should get rid of a significant chunk. So that was 13.5. Let's just see how much this could help already. Because this is a tiny change. And I'm hoping that by getting rid of the bigger ones, then the important smaller ones will start to take more space and sort of reveal which ones are important. Okay, I didn't do that right. Oh, shoot. Okay. What did I do wrong here? Sort. Oh, wait. I'm calling M parent children. That's because it was done in a child before, so that's clearly not right. Okay. So let's go back to GitHub and get ready with our profiling machine. Load time is not great. I mean, it's pretty fast for what it is, but I think we do have some issues in our, either in the TCP implementation or somewhere in the networking layer, that we're just taking a bit too long to get packets sometimes, but that's not really what I'm going to focus on today. So why is the code not showing up? Do I have to resize to get that? Oh, maybe, okay, maybe it didn't show the file list without a resize. Okay, so now we're doing these. It doesn't feel like meaningfully faster, but let's see what the profile says regardless. All right, look into that. Okay, so the quicksort is definitely gone from the top. Where did it go? It's all the way down here at 0.6%. So huge improvement, getting rid of that 13.5% down to 0.6. We are going to definitely commit that. So libweb sort stacking context tree once after fully building it. Instead of calling quicksort every time a stacking context child is added to parent, we now do a single pass of sorting work after the full stacking context tree has been built. This before this change, the quicksort was 13.5% of a profile, 13% of the profile while hovering links on GitHub and the browser. After the change, it's down to 0.63, 0.6%. Yeah. Pretty good. That is pretty good. Okay. So who's at the top now? Well, there's the syscall, but it's kind of all syscalls. Or rather, it's this madvice, which is really a symptom of malloc. So let's skip over that one for a moment. We'll get back to it, but now we have another double-digit guy right here, Pseudoelement. So let's go look at that. Okay. So selector Pseudoelement. The purpose of that is just to answer the question, which Pseudoelement does this selector have? Okay, so a selector, a CSS selector in Serenity in the web is one of these things, right? Like foo, bar, baz, fim, bam, something like that. Like you would see at the start of a CSS rule. This guy here is a CSS selector. If you have a rule that has multiple selectors like this, you know, these are individual selector objects, and the rule just has multiple selectors, but this is one selector. And so when we're asking about the Pseudoelement from a selector, what we're really interested in is if the subject, so the last simple selector, the last sort of part of the selector on the right-hand side has a Pseudoelement. So one of these : something Pseudoelements. And as far as I know, the Pseudoelement has to be on the rightmost side, I think. I feel like you can't have, is there such a thing as a selector validator? Validate selector expression. Wait, that's not what I was looking for. I think you can't do like this, right? After. Because that implies that you would be selecting on the on a DOM relationship between some descendant or child or sibling or whatever of a Pseudoelement, but Pseudoelements are not actually real things in the DOM, so I think it has to be the rightmost only. So really this function just needs to, oh wait, what does it say here? This assumes that only one Pseudoelement is allowed in the selector and that it appears at the end. This is true currently, and there are no current proposals to change this, but you never know. Okay, so that's kind of what I was musing about. That was added by Sam. Thank you, Sam, for noting that. Yeah, I think that's definitely the case. So this just has to look at the very last simple selector and see if it has a Pseudoelement. So it seems to me like we could cache this instead of, because if you look here, what it's doing is that it's walking these from checking if we have any of these compound selectors, and then it's looking at the very last one. So in a compound selector, these are 3 parts of a compound selector right here. So foo is one, bar is one, and bar fim bam is one, baz fim bam. And we're only interested in looking at this one, if it has a Pseudoelement. So I think it's doing too much work here already, because it's sifting through, like you couldn't write one that looks like this, right? Wait, what am I trying to do? Style. Foo bar. After .img, right? That doesn't even make sense. I wonder if Firefox will just complain about that. Doesn't complain about it. Is that a valid selector? It doesn't feel like a valid selector. Yeah, okay. I'm not actually sure if if that's valid or not. So I guess I'm not gonna mess with it. We could look it up, but I'm just gonna leave this alone. And then if it turns out that that's not even something we need to support, we can make it even simpler. But what we are gonna do is we're gonna yoink this stuff right here. And instead of doing it every time you call, we just do it in the constructor once and then remember it. So we'll add a member to cache this because it's never gonna change across the lifetime of a selector. So since it is 10% of runtime currently, we will just do this and we'll have this guy return it. Inline, very, very nice. And then I guess we'll have to, we can't just return like that here. So we'll have to do something like this instead. Compound, no, Pseudoelement is this. Yes, and then we'll break here. Yeah. That should probably kick that 10% off because we construct the selector after parsing it. And if we only have to figure out the pseudoelement of the selector once when parsing it, then we never have to do it again while doing style computation. Should apparently save us a whole bunch of time. So let's find out how much. Seems I have to rebuild a bunch also, but I'm really optimistic about this change because selectors are fundamentally immutable. You can't change the internals of a selector after creating it. Like it is created by passing in a full set of fully formed compound selectors. So it doesn't have any way to mutate it. Okay, so while we wait for that, I'm just going to craft a commit. Cache CSS selector Pseudoelement at construction time. Pseudoelement. Computing the pseudoelement of a CSS selector was very hot when mousing around on GitHub in browser. Profile had it at just about 10%, right? And then we'll amend the commit when we know how much less. But I think it will just disappear because now we'll just be returning this thing here. So like the negligible construction time of a temporary optional should be all that remains. And then we'll see what else we can do. Okay. By the way, it is pretty sweet to see a page like GitHub actually loading and starting to become somewhat usable in browser, even though it's still obviously there are layout issues, but layout is substantially better than even it was a week ago. And we're just going to keep improving it. And now we're going to do a little bit to make performance less obnoxious. Because you can see here, like, it paints pretty nicely. Looks pretty good. Little issues here and there, like these guys are not floating to the right properly. Alignment's a bit goofed. We got SVGs looking not super great, but can definitely work with this stuff. Okay, so still very, very sluggish, but let's get one of these things. Okay. What's at the top now? We have a drum roll. Aha! It's totally gone. Looks like. What's it called? Pseudoelement selector. I'm just gonna try to search for it. Web, CSS, selector. Yeah, it's not here. I mean, I guess it was inlined somewhere. Who's actually calling it? Oh, only one place. Matches, selector engine matches. Incidentally at the top. But that was in the top previously as well. Also, wait, this is not the function that's in the top. This is the one that has an int argument in the middle. This one doesn't have the int. This one calls the one that has an int. Yeah. Okay, good. So Pseudoelement is basically gone. Fantastic. We'll amend this. Profile had it at 10% after these changes. It's totally gone from the profile. Cool. Okay. So selector matching. Now that's a bit harder of a problem, one that we've already attacked a bit by, if you saw the video I made about optimizing CSS selector matching by dividing all the selectors that we have into buckets and then only running selectors that have a chance of matching an element. So like for every element where we want to figure out which selectors match this element, we filter through our sort of pre-created buckets of selectors, for example, based on the ID or class attributes of the element or the tag that the element has. And we try to run only the relevant selectors, the ones that have a chance of matching. So we've already done a bit of work, but it is very heavy here. So we can probably find a way to maybe improve our bucketing, like put more stuff into finer buckets or something. We should look into that. But I'm kind of interested in this hash table thing because I feel like that's also what's causing the top one. Yeah, so it is the hash table that we have for custom properties. So let's look at that code. So that's in compute cascaded values, right? Cascade custom properties. So the custom properties are the CSS custom properties or CSS variables, which are basically variables that you can set in a CSS rule and then use in other CSS rules. It's just variables, right, for CSS. And the way that we cascade them is because you inherit variables. So if your parent element has a bunch of CSS variables that apply to it, then they should apply to you as well. So it's inherited down the ancestor chain. And we implement that here by, let's see, what do? We create a hash map. First, we're computing how much capacity the hash map is going to need. And then we make a hash map, reserve that much capacity. Then we go through all of the, oh no, not all of the parents. We just go to the one parent and get all of the parent's custom properties, insert them into our custom property map. And then we go through all the matching rules for the element and get all of the custom properties from the matching rules and insert them into the custom property map as well. And then we put the custom property map as a cache on the element. So effectively, what ends up happening here, let's take a look at one of these elements, is that we can actually see the variables here. We click on something that has variables. Yeah, so in the variables tab, you can see all of the variables that apply to a given element. And there's actually quite a lot of them here on GitHub. Also, these colors look strange. I don't know if that's a serialization bug or if that's a valid way of saying a color, or I don't know. Anyway, the thing I wanted to show you here is like every element has a cache of all the custom properties that apply to it. Maybe we should put custom properties here instead of variables, because the ambiguity with custom properties and variables is kind of annoying. And like using different names for them in different places in our own code base is probably not great. But every element has this custom properties map. So it's stored with the DOM element, and it's everything that you see here. And what immediately comes to mind for me is that the way that we construct this is pretty wasteful, right? Because like, why should every element have a copy of all of the custom properties that they inherited? And can we save a bunch of time by, instead of copying everything that we inherit, by just having the, like if somebody wants to get the value for a custom property, if we don't have it at the element, well, just go up the ancestor chain and ask the parent and his parent and so on. I suspect that would be a lot faster than making all of these copies everywhere. Because accessing the properties is not necessarily the common case, right? So we're probably spending a lot more time setting these things up than we are accessing them. So what if we just try to change the way this works? So we would basically not need capacity for the parent properties. So we don't add the parent properties, and then the element would only store stuff that was specifically added by selectors matching on that element, not stuff inherited from parents. And then we don't need to, I guess we can just store it on the element. We don't need to return it here. And then let's see, custom properties, and then we don't need to pass that around. So we can stop passing that around. Custom properties. Yeah, we'll just nuke those. Okay, and I'll have to get rid of the arguments, or parameters rather. Here, you be gone. You be gone. Okay. I'm just going to bring up the problem view. Okay. Not too much stuff to change. Okay, so now we're not going to pass these around anymore because we know that they're already stored on the element anyway. And then when we want to access custom properties, so get custom property, what this lambda does here, wait, who used that? Okay, so we just see if something is a custom property by looking it up. And we do that by checking in that hash map that we had. Yeah, of course. Okay, so this can just change really to be, we'll pass the element to it. And then we'll make it a standalone function instead. So ref footer style value, I guess. Get custom property. DOM element const. And flight string const. Custom property name. Okay. So the way we find it is by asking the element. find the custom property name if it is not element custom properties end. Actually, wait, do we have one of those is end things? No? Okay. If that works, then we return it value dot value. And then we have to go up the chain of parents of element if this doesn't work out. So current element, I guess. Element, current element, and current element is current element parent element. Okay, so, and if we don't find anything, we return null footer. So what does this do? So we start at the element, and we ask if the element has a custom property with this custom property name. If it does, we return the value that the element has for that custom property. Otherwise, we go up to the element's parent element and ask again there. Except I typed the wrong element here. Yeah. And over there as well. Okay. So if we do that, we should see way less malloc traffic, I would hope, because it's just going to be... Because I think the way that this is usually set up, at least, is that you would have like a bunch of variables at the root element. So like on the HTML element on the GitHub page, they would have like all these variables. And I guess we can look at it here, actually. Let's use Firefox. Firefox and Chrome and those guys, they definitely have a bit better dev tools than we do. Because our dev tools are like printf. But maybe we can work out where the variables are. Do they have something to show that? I don't know exactly how they do that. Where do all these come from? These look like a lot of variables down here. What am I looking at? Can I make this bigger? Yes, I can. Look at all these things. Yeah, so there's like a lot of variables on the root element. Again, same thing here, root, and also based on your color mode. So the color theme, I guess. So I think basically what I'm getting at is that the variables are often set at a high up node in the DOM, and then they just trickle down through inheritance to everybody. So what I'm hoping here is that most elements won't have any custom properties of their own, and instead they will just inherit them, and we'll just climb up the parent chain to find the inherited properties. We'll see how it works out in practice, but can we look at a random thing? Like, what if I look at one of these things, right? And I can see that it has all these properties here, and where do they come from? At media. Data dark theme. And who has data dark theme on them? Because these guys don't have data dark theme on them, so... Who is data dark theme? Oh, wait, the HTML element is. Yeah, data dark theme. So they're inheriting it from the HTML element. Yeah, exactly. Okay. Now that it has built, we can stop guessing and see if it helps. Okay, well, now it's definitely starting to feel a bit better. Still sluggish for sure, but anecdotally it feels a little bit better. Okay, and then let's see if I was just imagining it. Seems like I was not imagining it because it's kind of gone. Custom properties. That's really cool. Compute cascaded value. Yeah, so custom cascade, custom properties. Yeah, that was the one. Web, CSS, cascade. It's not even here. That's really good. So seems like a huge win. And look at that. Selector matching is now at almost 30% of the profile. So rapidly climbing here in relevance. And this actually reminds me of WebKit a lot, which, as you probably know, I used to work on in the past, where like selector matching, eventually, like as the engine became more and more optimized, selector matching was always one of those things that we just had to keep coming up with new ways to optimize selector matching because people kept adding more and more selectors to their style sheets. And it's funny that we're starting to run into the same thing here, that selector matching comes out. And this is definitely going to require a bunch of work to get this going faster, but a lot of things we can do. Anyway, let's make a commit out of this stuff. So, oh, we're going to have to also fix the inspector, by the way, so that it shows the custom properties correctly, because now if we look up the custom properties here, it's not going to include what we inherited, right? Yeah. You don't see what you inherited. You only see if you go up here. We don't even see them here. Wait, that doesn't seem right. Why can't I see them? Okay. Oh, maybe they're not where I think they are. Well, I'm not seeing anything, so that's definitely a problem that we need to address. So let's see. Custom properties, but like they're clearly working, right? Because they are still showing, the page still looks correct. If we fail to assign the custom properties to the element, we should get a totally bogus looking page. Let's just verify that, because I mean, it's obviously going to be faster if I don't even process any custom properties, but I would imagine that we would have seen a bigger problem with the page if I didn't. But maybe I'm totally wrong. We'll find out. No, this is what it looks like if you don't have your custom properties. Actually, not a half bad theme. Reminds me of JCS and his Mac OS antics. That he's always working on this stuff. Kind of looks a bit like that. I don't know. Anyway, yeah, so it's working, but they're not showing up in the inspector. Okay, so why is that happening? Custom properties. How do we expose them? Element, custom properties. I would assume that this is what we call in order to, I mean, this is what we call when we're looking for the matches. Get custom properties, right? But we should also see, where is that? Here, when we're serializing the node state to pass to the inspector, then we're doing that right here. I guess what we should do here is just walk the DOM. But in this case, we need to walk from the, we can't walk from the element up to the parent, because then we will overwrite. Or I guess we can, I mean, what's the easiest way to implement this? Because it's not performance critical with the inspector. So actually it already takes care of that if doesn't contain. Yeah, so we could just walk. Wait, is it already doing that? Element to check parent element. But it's already walking up the chain here. Wait, this is what I was gonna do. That's so weird. So why does that work? Why doesn't that work, rather? Custom properties. Oh, I have to, I am so surprised. Okay, let me go ahead and, where was that code even? Oh, here. So I'm just gonna add a bogus property here and see what happens. Bogus. And I will put it right here. Bogus mogus. There we go. Serialize custom properties. Yeah, so we should at least get a bogus mogus. Let's test it out. Okay, bogus mogus definitely showing up. Let's look at our page that we have a test page for custom properties, custom properties. It's only, okay, so this one should definitely show something. Why don't they show up? Also, this storage here. No. I am perplexed. Do we do something like element.clear custom set custom properties? Now I'm thinking like, are we removing the custom properties somewhere? M custom properties. Okay, let's try this out. Assigned custom properties to element. Okay. Sure, no custom properties here to think about too much. But what if we look at this one that has custom properties? It has a bunch of them. 30. HTML, yeah, so this guy has many here. Sure. Okay, so are we messing this up when doing the walk? Maybe I didn't read that code correctly. Here, element to check is element. While element to check, go to parent. Element to check is parent element. definitely looks okay. Debug line. Get custom properties offer. Element debug description. Okay. Let's find out what's going on with that. So an interesting thing here is that the web content runs in one process and the inspector runs in another. So we have to like turn everything into a big JSON blob that describes the state of the page and send that over. So that's why we're doing the serialization to JSON of everything. Okay, so what's going on here? If we, dang it, we inspect element, should be purple. Oh wait, this it looks a bit alarming. What's going on here? Oh wait, does it have the exact same bug that I was that I was gonna have? Element to check is element to check parent element. Oh no, I added the same bug. Dang it. Oh, I made the same mistake. Not printing the right thing. If doesn't contain property key. What is the problem, Andreas? How did we mess it up? That's what I want to know. Okay, so it's walking up the chain, clearly, but not finding the custom properties. So let's print out how many of these guys have custom properties and how many. So element to check custom properties size. And then I guess we can print each property as we come along it. What is this scene properties thing? Just a hash table to not have the same property many times? This is so strange. Okay, so now they have 0 custom properties. But previously they had some. Properties. Custom properties dot. There's no clearing going on. Oh wait, I'm looking in the wrong place. What? I don't know why. I feel like it's being cleared somewhere, but I don't know what would be doing that. Because there's no reason to clear it, right? Put custom properties on element. I am confused, but we are going to figure it out. It's funny how the optimization itself is easy to do, but like it breaks something a bit surprising, and now we have to figure out how and why. Okay, so we have custom properties on HTML here. Sure. But it claims to have none of them. Okay. HTML, 0 custom props. HTML, 7 custom props. Mm-hmm. Hmm. And there was no like, well, okay, wait, hold on. Are we running this again and producing 0 properties for some reason? I am gonna have to find that out. So I guess we'll have to print out in every case. And then let's also print out the pointer to the element, because now I'm not trusting anything anymore. So let's get the element address to make sure that we are talking about the same actual element here. Because what? Element to check, right? Yeah. Okay. Wait. Oh, now I'm not printing anything. Ugh. Yeah, of course, because now I've moved it. Okay, I'm just being stupid. Okay. Okay, wait. Here it is. Put 0 custom properties on element. HTML. And then where are we putting some on HTML? 7 on HTML. Ends in 32A0. Ends in 32A0. Interesting. So it runs again later, but then we don't find custom properties? What? What on earth? What on earth is happening? Cascade custom properties. I wonder if this is related to Pseudoelements. Like we're trying to come up with something for the Pseudoelements of HTML. So I guess wait, what does that mean? What if I only do this pseudoelement, if there's no pseudoelement that we're looking up right now? Because the way that pseudoelements are implemented is that you pass along a pseudoelement. So if you want sort of the after pseudoelement of an element, then you say the element, and then you say here that actually I'm interested in the after pseudoelement, which I guess would mean that we run the selector for the after thing, and then we are assigning custom properties to the element, but not to the pseudoelement, but they get stored on the element, which would explain this strange behavior. So now they are here. Okay, yeah. So that was a problem. Oh my goodness. Okay, that was very confusing. This means that I'm basically breaking custom properties for pseudoelements here by not returning a hash map to use. But am I? because they still get stored on element. Okay, I'm going to break this now and leave it as a fix me to look into custom properties on Pseudoelements, because I don't know exactly how they should work anyway and how we should optimize them. So fix me, look into how custom properties should interact with Pseudoelements and support that properly. Yeah, because I don't know exactly how we should do that, but Pseudoelements are a relatively new feature in the engine, so so I was not like, I didn't have it in my mental model well enough to understand that it was breaking the thing here. So that's fine as a fix me, I think, though. So let's add that. Get rid of that. Logging, sure. Okay. libweb. So where were we? Before I got distracted by this problem. Basically, avoid don't make deep copies of custom properties for every element. Deep copy. Let's say deep copy. Note that this may break custom properties on pseudo elements a little bit, and that's something we'll have to look into. Okay, so let's see. Previously, we were making a copy of the full set of custom properties that applied to a DOM element after computing style, or applied to a DOM element. Yeah, this was very costly and dominated the profile when mousing around on GitHub. Mousing around on a page is a nice performance test of any web engine. It doesn't sound so fancy or official, but I like it. Mousing around on GitHub. So let's see. So what else was going on in the profile? Get back on the horse. Get a new profile here. GitHub. Oh, doesn't want to load. Let's try again. Come on now. There we go. Okay. A little bit annoying that I'm probably resizing to different sizes every time I do this, but you know, it's the thought that counts, right? Like, it doesn't have to be super precise because we're just looking at sort of what's at the top of the profile, right? We're not super concerned with exact numbers at this point because the numbers are so big anyway. So let's try to find something to improve. Okay, yeah, so selector matching, definitely at the top, definitely heavy, sure. Then we have collect the matching rules. Also pretty heavy, 5%. Checking if an element has a given class called by selector engine matches. Yeah, so that's a heavy thing. What else do we have? We have memset and malloc in collect matching rules. Oh, I bet we can, let's see, compute cascade values. Yeah, I was gonna say like we can just put some inline capacity on that thing, but then I also noticed that this is recursive, so it's not necessarily very nice to use a bunch of stack space in a recursive call stack. So let's not toy with that too much. But oh, this guy right here that I was commenting on earlier, property initial value, which was originally at 1% or so, now is at 2.8. I bet you that that's doing something silly. I think we generate that code. What was it called? Property initial value. Yeah, and it's being generated here. And what does it do? It makes a hash map of property ID to the initial default value of every property. And then it initializes it once by parsing the initial properties. Then it will just return from that hash map. And isn't it silly that it's using a hash map when it could also just use an array? Because if we're going to have one for every property ID anyway, we might as well just make it a flat array and save ourselves the trouble of hashing. And I bet you that this will also just peel off if we do this. So I guess we can't use non-null ref putter in array because we're going to have to default initialize here. And we don't need property ID there. Instead, we have to say how many we have. So that's going to be, I guess we can use there's some like last property ID thing. Yeah, this guy. I've used this before for something. So this one plus 1 is the number of slots that we need. And instead of checking is empty, I guess we can just do this, right? Oh, true. And then at the very end, we don't have to .find, we can just do an array access. There's no value. Yeah. Where do we add to the thing? Here. Instead of set, again, just do simple array access. This is going to be real nice, actually. Okay. Yeah, I think that one is going to melt off. Let's see, property initial value. Oh, wait. I didn't rebuild code generators. I mean, it's not the biggest thing, but if whatever you can get for free, we should just take, because this is clearly better. Like when something has better speed and space characteristics, then you should just take it. Okay. This is starting to, I mean, it's still terrible, but but it feels nicer than when I started. So let's get a little bit of that profile action. Okay, good enough for me. It's nice to sort of systematically go through these things one by one and trying to improve one at a time. Okay, so where did you go, property initial value? I don't see you. CSS. Wait, let's look for it. Web. Oh, no, that's not what I wanted. What did I do? Web, CSS, property initial value. Oh, here it is. Okay, so 0.73%. It's not quite disappeared, but down from 2.8 to 0.7. Definitely worth doing. since it's better in every way. So libweb make CSS property initial value use an array internally. Since we store an initial value for every CSS property ID, since we want to store an initial value for every CSS property ID, it's pretty silly to use a hash map when we can use an array. This takes the function from 2.8% when mousing around on GitHub all the way down to 0.6%. All right. That's nice. Okay, what other kind of nonsense do we have here? Now I'm kind of feeling ready to wrap up, but there is one little thing here, like this stir comp. This is usually runtime type information, dynamic cast, which we can probably just get rid of. So we have an interesting relationship with our TTI in Serenity in that we have it enabled so that you can use dynamic cast, but whenever it shows up in a profile, we add a helper function to make it faster, which usually just makes it go away from profiles. And it sort of gives us the convenience of having dynamic cast, but we have an easy out whenever it is slow, because dynamic cast, at least in this implementation that we have here with GCC on Linux, it uses string comparison to check if one class is compatible with another. And as you can see, it's like string compare is at 1.14% of the profile, and that'll all come from dynamic casts, I think, or somewhere in the API helpers. So we can, I'll show you what I normally do. So we have, let's see, we have this layout block level children. Usually what I would do is I would look for these is things. This is our helper for this. And see, okay, so this thing is missing a fast type checker, so we can add one for that one. Replaced box, also missing. Block container probably has one. Yeah, there we are. Okay, so I'm just gonna add for list marker box and replace box. Yeah, so this is what I normally do, is replace box, and then we just have that as a virtual. Layout node.h. As you can see, there's already a bunch of them. And it says here that they are used to optimize hot IST variants. And this is a pattern we use in many places in the code base. Parent or shadow host. Oh, wait. Let me do a couple more. We also had list marker box. List item marker box even. Is list item marker box. Sure. And then parent or shadow host checks is a shadow root. Okay, so shadow root probably doesn't have one either. Yeah, so we'll just add one here as well. Is shadow root const final return true. Okay. Wonder if that's going to be enough to get rid of it. We'll find out. It'll be a little bit of a rebuild, but I mean, it's really straightforward. So let's just commit those. Just see that I got them right. Default to false, return true, and subclasses. Sure. Past is T helpers that were for hot classes on GitHub. Yeah. Okay, so selector matching, definitely an area where now starting to become clear, because it's like 30% or so of time spent mousing around is in selector matching. And I think I'm not gonna dig into that too much today because I'm pretty happy with the progress we've made, but it will be a great topic in the future to implement some more sophisticated selector optimizations and see what we do with that. I think that's going to be fun. But yeah, I mean, we've already done a whole bunch of really awesome things here, and I like that the syscall stuff with the madvice, that it kind of just went away when we stopped producing the deep copy of the custom properties for every element. We are, yeah, as I mentioned, we are going to have to come up with a solution for Pseudoelements, but I think we'll have to think about that one a little bit to figure out exactly how we should store those. Because I guess you can put custom properties that apply only to a pseudoelement, right? So those need to be stored somewhere. But I don't want to have I don't want to have a full copy of everything. All right. Let's run this and see where we end up. GitHub. Something that's really nice about this approach, by the way, is that we're just sort of making engine general optimizations, right? Like they're not really targeted to GitHub. They're inspired by GitHub, but all of these things are going to help every page basically, which is really, really nice. Okay, let's get a profile, see where it ended up. Wow, look how many commits we have. 35,561. That's quite something. Okay. And open that up. Yeah. So selector matching at the top, as expected. Element attribute lookups. Definitely something we can look into. What is this? String, like looking for a string within a string, presumably like attribute contains selector. We might be able to exclude elements. If there are a lot of attribute selectors, you could potentially bucket by attribute and skip over a lot of selectors. See. I guess we can implement that also. It wouldn't take that long. We have the rule cache, which has rules by ID, class tag name, and pseudoelement. So what if we would add a rules by attribute name here? And then let's see, build a rule cache. Yeah, so let's print out well, actually, first thing, let's take a look at their style sheet. to see if it has a lot of attribute selectors, because it's wait, where do we see that? Style editor. Wait, how do you know which one is the biggest? Oh, it shows how many rules they have. 1690 rules. These all have the same number of rules? Or no? Okay, I'm not really understanding this. I guess what they're referring to, like some file that has 1690 rules and they're all sort of part of that or something because of some packing of everything into a single unit. Anyway. I just want to see all the rules. Where can I see all the rules? Network. Okay, show me the CSS. Okay, let's reload. Who's the biggest CSS? This guy right here, GitHub .css. Perfect. Not the most readable, but copy URL. I can fetch that. I can prettier that. Okay. So what are we looking at here? A lot of class selectors, tag selectors. Yeah, very heavy on classes. How many lines we're talking? 11K. K. Classes. Pseudoelements, sure. Okay, so I mean they are using attribute selectors. So I wonder if there would be any benefit to this. Let's see how many we could catch. If we just count them, see how many we would get here. Dun. Rules by attribute name. Simple selector attribute name. Attribute name rules. Okay, and then let's not forget to print that out. And collect matching rules has to look in the attribute buckets as well. So like element dot for each attribute name, and I guess we can just skip over the value and just say if auto it is m rule cache rules by attribute name, find attribute name if we have such a bucket. Then rules to run extend IT value. Oh, I guess that's the whole thing we need to do to implement that feature. Okay, so let's see how many attribute rules we actually end up in the rule cache, just to tell if that was even worth it. Because we had a bunch of attribute rules, at least in the profile, because it is pretty heavy to look for, like, does this element have an attribute of this name that contains a string that looks like this? Here's an example of an attribute selector. Like here, it has to have attribute type if it's to be a match. Don't know if this is going to be useful. I mean, I'm just like eyeballing now, but I'm not seeing super many. Here's an attribute selector, because it's really only the rightmost simple selector that matters for this rule caching. Everything on the left of that is irrelevant, but here these will get caught in the attribute cache. I mean, it will tell us once we run it now how many things it put into the attribute rule cache. So we'll get some kind of a percentage or whatever, inform us about the usefulness of this thing. But it really looks to me more like a class heavy page, class heavy style sheet. Which makes sense because we did see element has class near the top of the profile at like 5% or something. So it is very heavily querying elements to see if they have a given class. And as class, classes is stored in a vector, so that's a little bit unfortunate. It's O of n lookup, but usually elements don't have that many classes. I suppose you could use some kind of a hash data structure, but I wonder if that would actually help or hinder, because normally you have so few classes that you have very nice data locality anyway, and you're just like comparing, say that you have 3 or 4 classes, so you're just comparing 3 or 4 pointers to the class names here. Let's see, not BRB. Let's see what this guy says. Get these little printouts of the cache. Okay, so there's a total of 7,266 rules. 78 of them could go in the attribute bucket. Yeah, so that's not super useful. And probably not the most worth doing at this stage. I'm not sure, because the downside of that, of course, is that now for every element we have to walk all of the attributes, whereas previously we didn't have to do that, right? So previously we only looked at class names and the ID attribute, but now for every attribute we have to go and like look up if there's a rule cache for that attribute. So I think this is probably nets more work in the end. And like with this proportion here, I don't think we should put more effort into that one. Class is clearly dominating, and I don't know if we would be able to somehow, I don't know, like reduce that and divide it into smaller buckets or something. But yeah, that's something to look at in the future. But I think we're going to be happy for today. We did a whole bunch of nice changes, and there's definitely a noticeable improvement in responsiveness, even though it's nowhere near where it should ultimately get to. I'm still pleased with this incremental progress. So this is going to be the end of the video. If you made it this far, thank you so much for watching and for hanging out. I hope that you saw something interesting here today. And as always, if you noticed something off and you have ideas for how to improve it, then please come and talk about it. We're always open to improvements, and always open to pull requests. And I get people asking me if it's okay to send pull requests sometimes, and of course it's okay. You know, we want people to join in the fun of hacking on this project. The only thing that I do say about that is that if you want to make some big changes, please don't do those in your very first pull request, but like do something simple first, just to get used to the project and our workflows and so on, and get used to communicating with people. And then sort of work your way up to bigger changes after we've learned the basics of how the project is developed. Anyway, thank you very much for watching the video. Hope you liked it. See you next time. Bye.